All right, here's a question from exercise 7B in the finance notes, question 14. Sarah's given $5,000 on her 18th, 19th and 20th birthdays. She invests it all in a trust that averages 12% return, or it did over the past 10 years, so we're going to assume that same thing for the future, and you'd write that as one of your assumptions. Her twin brother Joshua is given the same amounts but uses the first $5,000 to go on a holiday and then puts the same amount in on his 19th and 20th birthday and invest it, and they both take them out when they turn 55. So the question is, how much more money does Sarah have at the end? Now, you can go ahead and just work out how much they have at each, at the end. So the easiest way to do that would be to work out how much they each have at the 20-year mark and then take those forward. So using just our future value formula, and that would then enable us to figure out how much they have when they turn 55. So we'll do it that way first, then I'll show you just a really fast way that if you're thinking carefully, you'd be able to actually figure out that you could do it this way and save yourself a lot of time. So we'll see how that goes. But first up, what have we got here for Sarah? She puts $5,000 in, then she pays another $5,000, then she pays another $5,000. If we get our little calculator up, and we're going to go to Tvm Solver. I'm just going to move that across a little bit so you can see everything that's going on. Tvm Solver, compound interest, here we go. So first up, the number of years. So 18, we're only going to go to 20. So this is 18, 19, 20. So it's only going to be for 2 years that it's going to be in there. The interest rate is 12%. So we've got that there. She starts off by putting in 5,000. So we're doing Sarah first. She puts 5,000 in on that account as a present value, and then makes another payment of 5,000. We're going to calculate the future value, but before we do, this is only happening yearly, isn't it? So we've got to change these payments per year and the compounding period per year to 1. So now we work out the future value by the time she's 20 and she puts in that last $5,000 payment. How much is she going to have in the bank? Sarah's going to have $16,872. $16,872. Now when we go ahead and work out Joshua's money, the only difference is that present value, he won't have invested $5,000, he won't have put anything in. He's just going to put $5,000 in a year's time and then $5,000 in another year's time. When we work out the future value for that one, $10,600. So not surprising, it shouldn't be too different. Was it 10,600? I've forgotten that number already. Double check it. Yep, that's all it is there. So, yeah, you expect it to be at least 5,000 more because there's interest rates. So 15,600 plus 2 years worth of interest, 16,800. 12% is pretty high interest rate. So she's a little bit better off. What does that translate to in another 35 years' time? Let's go ahead and figure out what that is once I can find where my little cursor is. There it is. So I want to find the future value of this. So the future value is going to equal the 10,600 multiplied by 1 plus 0.12. So that's just 1.12. And that's going to happen for 35 years. So we find the future value of that. Of course, we can do it just using our calculator as well. So let's just do it that way. So the present value at that point in time, he's got 10,600 invested. He's not going to make any more payments, so we can put that down at 0. What's the future value going to be? Something's not right there. I didn't change the number of years, did I? 2 years, we want it to be 35 years. Now we go ahead and calculate the future value. 559,675. 559,675. And there were a few cents there. We'll quickly go back and add them in. 0.97. And hopefully you can just see me squeeze that number in there. So he's done all right for himself, hasn't he? 559,000. And he put in a total of 10,000 all up. Had to wait a fair few years, but he ended up with quite a tidy sum. What about Sarah? Now the difference here is instead of 10,600, it's 16,872. So all I've got to do is change that number, 16,872. Working out the future value, 890,835, and was it 18 or 19 cents? 890,835 point. Let's see if I wasn't really paying enough attention. 890,835.18, and so therefore you've got the difference, which is just one of those minus the other one. 890,835.18. Subtract 559,675.97, and you get your answer. So we'll quickly do that, and then I'll show you the way that you could save yourself a lot of time while you're doing it. So 890,835.18, and we subtract 559,675.97. 331, 159, and 21 cents. 331, 159, and 21 or 29 cents. Don't remember. Too many other things going on in my brain at the same time. 21 cents, so we can just fix that up. So pretty easy, pretty straightforward. I find it easiest to get them to where the annuity stops and then just use my future value formula. So using that future value formula or Tvm Solver, either one's fine. Be confident using both. But what was this fast way I was talking about? Well, here in year 19 and year 20, they deposit the same amount. So the money they put in at those times is going to add up to the same amount in the future. These two $5,000 payments that Sarah puts in are going to add up to the $559,675.97. The extra difference, this $331,000, must come from that initial deposit. And if we go back and just look at what would happen with an initial deposit of $5,000, got there eventually. So instead of being 35 years, it's going to be 37 years. We're just looking at that very first payment when she was 18. How much she invested? 12%. That's still right. Next one down, we're only going to make that 5,000. No extra payments. What would the future value of just that $5,000 be? And you can see 331,159.21. So that's responsible for the difference. So you could have just said, well, that's the only difference, and gone straight to just find the future value of that, and you would have had your answer too. Hope that helps. Good luck. Get plenty of sleep, and we'll see you tomorrow. Bye.